Hey everyone, and welcome to another deep dive. Today we're going to roll up our sleeves and dig into a topic that's, well, let's face it, it's bread and butter for any web developer working with databases, especially when you want to add new information securely. We're talking MySQL insert queries, making sure all that user data or product info lands right where it should without opening any security loopholes.
Right on. Security is job one, right?
Yeah.
And when we're talking about databases, the heart of so many web applications, we really got to be on our A game.
Yeah, no kidding. We're talking Fort Knox levels of security here, right? So today we're going deep on how to use insert queries securely in your MySQL code. And we're not just going to tell you what to do, but why it matters. So you can build those web forms and functions that interact with your database with confidence.
Absolutely. And one of the most critical concepts to wrap your head around here is prepared statements. See, when you're inserting data, you're often dealing with information that's coming directly from your users, often through forms on your website.
Yeah, that makes sense, but I can already see where this might be a problem if we're not careful.
It definitely can be, yeah.
Hmm.
Imagine someone figures out how to sneak their own malicious code into, say, a username field. If you're not using the right security measures, that code could end up getting executed by your database. Not good. We're talking potential chaos right across your entire system.
Okay, yeah, I'm starting to see the danger here. So are prepared statements like our first line of defense then?
Exactly. Instead of just blindly inserting user input into your SQL query, think of a prepared statement as a kind of template. You've got the structure of the query, but with placeholders for the data that will get slotted in later securely.
Ah, okay. So it's like saying, here's the basic framework, but I'll fill in the specifics later.
Right. You're basically telling MySQL, this is the query I'm going to execute, and these are the types of data I'm expecting. And those placeholders, usually represented by question marks, that's where the actual user data will go safe and sound.
Okay, so these placeholders are what stop malicious code from being misinterpreted as an actual command.
You got it. And this is where parameter binding comes in, usually with a method called bind param. Let's say you have a simple user registration form, username, password, that sort of thing. With bind param, you're attaching those values from the form fields to the placeholders in your prepared statement.
Oh, I get it. So it's kind of like one of those claw machines at an arcade. The claw is bind param. It grabs the user input and puts it directly into the correct slot, the placeholder in the SQL query.
Love the analogy. And the important bit is this MySQL then sees that data as, well, just data, not executable code. It basically neutralizes anything nasty a bad actor might try to slip in.
This is making a lot of sense. Now, I noticed in the code examples we have for this episode, there's this IOZ string that shows up with bind param. What's that all about? It seems kind of important.
Nice catch. That SEZS string, what that's doing is defining the data types that will be bound to those placeholders. Think of it as a way of telling MySQL what to expect. ES means it's a string, E is for integer, ED stands for double, for those decimal numbers, and B is for a blob, which is used for larger chunks of data.
So it's like we're carefully labeling those containers, making sure MySQL knows exactly what's inside each one. Smart. But even with all these precautions in place, it's always good practice to double check our work, right? How do we actually know for sure that our insert query did what it was supposed to do?
You're absolutely right. Never assume anything in programming. And the good news is MySQL gives us some handy tools for this. One that's really straightforward is affected rows. Pretty self-explanatory, tells you how many rows in your database were actually changed by the query.
So if we're doing a simple insert adding one new record, we should expect affected rows to give us back a 1.
Exactly. If it returns 0, that's a clear sign something went wrong somewhere. The data didn't get inserted like it should have. Now, another useful tool, especially for tables that use an auto-incrementing ID column, is insert.
Ah, so this comes in handy when it's the database itself that's assigning a unique ID to each new record.
You got it. Inserted will give you the ID that was automatically assigned to that most recent record. Super useful for things like linking that new record to other parts of your application.
It's like getting a receipt with a confirmation number. You know the database has received and processed your request. This deep dive into the object-oriented approach to MySQL and insert queries has been awesome, really insightful. But I'm wondering, for those listening who might be more comfortable with a procedural style, could we take a quick look at that too?
Absolutely. Think of it this way. Both object-oriented and procedural are just different paths to the same destination. They both get you to secure data insertion in MySQL. They just use slightly different syntax along the way. Choose the one that feels most natural to you, or the one that fits best with the project you're working on.
Yeah, it's like having different route options on your GPS, right? Different ways to get to the same place. So, for those who might be new to the procedural style, what are the main differences to keep in mind?
The biggest difference you'll notice is in how you call functions. With object-oriented, we were using that arrow notation, like with empty bind of param. In procedural style, you'd use a function like MySQL bind param. The function names for preparing statements, executing them, and so on, they're all very similar, just structured a bit differently.
So, same core concepts, just a different look and feel depending on which style you're using.
Exactly. It's more about personal preference and keeping your code.
Now, switching gears a bit, I'm always interested in how to handle those date values when we're working with forms and databases. I mean, we ask users for dates all the time, but MySQL has its own way of wanting to see them formatted, right?
You're right, dates can be a bit of a special case. MySQL likes its dates in the YYYMMDD format, which may not always match what you get from a user.
Right, so year, then month, then day. Very specific. What's the best way to handle that potential mismatch?
Fortunately, PHP makes it pretty easy to convert date formats. A common approach is to use the datetime object. Think of it as your multi-tool for working with dates and times in PHP. Gives you the flexibility to format dates in all sorts of ways, including that YYYMDD format MySQL wants.
So even if someone enters a date in their own way, we can reformat it behind the scenes before it gets anywhere near MySQL.
You got it. And while we're on the topic of potential formatting headaches, what about those times when a date field is left blank? Happens all the time, right?
Yeah, for sure. Sometimes you don't want to force someone to enter a date if it's not absolutely necessary. How do we handle those empty dates making their way into our MySQL database?
Another good question. The good news is MySQL handles this really gracefully with what are called NUL values.
Oh.
You can actually store a NUL in a date field without any issues. The key is to make sure our PHP code is ready for those empty dates coming in from the form.
Right, we don't want to send something over to the database that'll cause things to crash.
Exactly. And luckily for us, the example code we've got for this episode shows a really neat trick for dealing with this. They use a conditional statement to see if the date input from a form has more than 2 characters in it.
So we're checking if there's actually something in there before we try to do anything with it.
Right. If there's more than 2 characters, we can be pretty confident that it's a real date, and we go ahead and format it for MySQL using that datetime object we talked about. But if it's empty, we just set the date variable to NLL before sending it off to the database. Nice and clean.
That's a really clever solution. It really highlights how important it is to think through those different scenarios, especially when you're working with user input. Never know what you're going to get.
Absolutely. And that brings us back to the main takeaway from this whole deep dive. Make security your priority.
Yeah.
Doesn't matter if it's a simple insert query or some massively complex database interaction, prepared statements, and parameterized queries are your best friends.
It's like they say, better safe than sorry. Right. Much easier to build those security measures in right from the start than to try and fix vulnerabilities after the fact.
Couldn't agree more. And as you move on to building more complex web applications with forms and database tables all talking to each other, keep those principles front and center in your workflow. It's about building those good habits that'll pay off big time down the road.
Make security part of your DNA as a developer, not something you just tack on at the end. This has been an amazing deep dive into MySQL INSERT Queries. We've gone from the basics all the way to some pretty advanced security stuff. I hope everyone listening is walking away with some really useful knowledge today.
Always a pleasure to geek out about secure coding.
And for those who want to explore a bit further, I'd really encourage you to check out the different database abstraction layers available for PHP. Something like PDO can make your database interactions even more secure and efficient. Until next time, everyone, happy coding.